Let's have a go at the very next question. The question appears to deal with the concept of moment. Let's start. Figure 2.1 shows a sign that extends over a road. So here's the depiction of the sign. The sign has a center of mass at its center, which is applying a force which is equivalent to its weight, W, as depicted. And this force is acting at a distance of 1.8 meter from the support post. Moving ahead, the mass of the sign is 3.4 into 10 to the power of 3 kilogram. We could use this further to calculate the weight. Calculate the weight of the sign. So weight is a force. Force is generally given by the expression F equals m times A. Weight is the force acted upon or exerted by a body by virtue of its acceleration due to gravity. So W is m times acceleration due to gravity g, which is approximated as 10 meter per second square. So the value of weight is m, which is 3.4 into 10 to the power of 3, multiplied by g, which is 10, and simplified, you get 3.4 into 10 to the power of 4 Newton. Moving ahead, the weight of the sign acts at a horizontal distance of 1.8 meters from the center of support post, and it produces a turning effect about point P. Point P is a horizontal distance of 1.3 meters from the center of the support post. Calculate the moment about P due to the weight of the sign. So here we have to first define what a moment is. Moment M is defined as a physical quantity, which is the equivalent of a turning force. So moment is mathematically defined as force times the distance d, where F is the force applied at a point perpendicular to a pivot, and d is the perpendicular distance from the point of application of the force to the pivot. Going ahead, we have the substitutions as force is the moment m is substituted through force and displacement or distance d. Force is 3.4 into 10 to the power of 4 Newton. And now to calculate distance d, we need to calculate the perpendicular distance between the point P and the point of application of W. This particular distance is exactly 1.8 minus 1.3, which is 0.5 meters. So that is the distance we multiply here, giving us the value of moment as 1.7 into 10 to the power of 4 Newton meter. The unit of moment is Newton meter, as stated here. Let's move on to the next part. Moving ahead, a concrete block is positioned on either side of the support post with its center of mass a horizontal distance of 70 centimeter from the center of the support post. State what is meant by a center of mass. A center of mass is considered to be a point on a particular mass or a particular body or a system of bodies such that the entire mass of the system of bodies or the individual body is concentrated at that point. So the center of mass, to repeat, is a point on a particular body or a system of bodies where the entire mass of the system is said to be or considered to be concentrated. Moving on to part 2. The weight of the concrete block produces a moment about point P that exactly cancels the moment caused by the weight W. Calculate the weight of the concrete block. So here we are going to reverse engineer what we did for the previous subsection. We understand that the moment caused by the weight, which is moment M, which is equal to 1.7 into 10 to the power 4 Newton meter. This is completely counterbalanced by the weight of the concrete block, which which produces a moment about point P. So we know that that point is at a distance of 1.3 plus 0.7, which is equal to 2 meters from the point P. So this moment, which is produced by the board, is equal to the weight of the concrete block, which is unknown, multiplied by the perpendicular distance from the point of application of the weight of the concrete block to the point P, which is 2 meters. So simplifying this further, we get the weight to be approximately or exactly equal to 8.5 into 10 to the power of plus 3 Newton. Move on to the last part. The concrete block is removed. The sign and the support post rotate about point P in a clockwise direction. State and explain what happens to the moment about point P due to the weight of the sign as it rotates. So we understand that as the weight of the sign is exerting a moment which causes it to rotate, the moment increases. The moment increases. The reason the moment increases is because the perpendicular distance, that is the value d. In the moments formula, we have m is equal to f into d. This perpendicular distance between point P and the point of action of W, this is supposedly also increasing. This increases because the force applied, which is nothing but the weight of the sign, remains a constant. And we understand that when one of the quantities remains a constant, the other two quantities, m and d, have either a directly proportional or an inversely proportional relationship. Here, since both the quantities on either side of the equal sign are both in the numerator, m is directly proportional to d, which leads us to this conclusion.